Testing 1, 2. Testing 1, 2. Oh man, so I keep looking at this circuit. Very intriguing. And I'm seeing some things. I'm seeing some things that tells me some things. All right, let me pick a color here. All right. So what am I seeing here? Seeing some things. Okay. So what I'm seeing here is the plus 9 volts here. This is what I keep focusing on. How this plus 9 volts is going through two resistors and a coil. So 20 kilo ohms and a coil. To potentialize positive on this Tesla vertical coil on one side of the coil, basically positive, potentializing it with positive. As well as this positive is going out to this side of the capacitor. And it's also getting to the other side of the capacitor, like so, and like so. Not that that matters much, and I think it does, I don't know, it might. But what matters here is, in my opinion, is this Tesla coil with the one wire positive on it. It's only getting plus right there. This is just aerial antenna symbol. So the plus 9 volts is, going this way, pretty much constant. Not being false, it's constant 9 volt potential there. And what I'm seeing is when these two gates are closed on these two transistors, one PNP, one NPN, and they get closed when the positive goes in the emitter out the base, and by the time the positive reaches the other transistor in the base out the emitter to negative, that will close the two transistors, okay? And then you'll get a plus here and a minus here on this coil. And this is a bifilar pancake coil sitting horizontal right there. That's the two windings. So everything transmitted to this coil through the battery is wirelessly transmitted to this coil. But in between this vertically, on the vertical plane, you have a potentialized antenna field coil called the Tesla coil with a one wire positive on one side. The other side is in the air. So what I'm seeing here is I'm seeing this plus. I mean, because the pancake coil is horizontal and the Tesla coil is vertical, I'm not really sure how the plus and minus is hitting the vertical coil from the horizontal. I'll be right back. Be right back. Sorry, duty calls. All right. Testing one, two. Good on the audio here. So what am I seeing here? Yeah, again, when these two gates close, you energize the one of the bifilar coil on the pancake side. Now let's set aside for now when the positive and negative hits the vertical coil, the Tesla coil. Because one's horizontal, one's vertical, I can't really tell. But if this is sitting horizontal, I would think the stronger field would reach to the top of the coil here. So I think the positive would probably hit the top of the coil, and the negative would hit the bottom of the coil. On the first forward action of battery charge of the single coil on the bifilar pancake. So when one winding of the pancake bifilar horizontal coil gets energized, let's just say it sends positive over to this side of the coil wirelessly and negative over to the bottom side of the coil. Okay? And then the gates open. They're now open. And the coil flies back in reverse polarity. And you have a negative here and a positive here instead. So now, the negative hits the top side of the coil and the positive hits the bottom. The whole time, this positive 9 volts from the battery is still there. Very low current, but a 9 volt potential is sitting there all the time. So as you energize one of the pancake coils, plus on the top and then and minus at the bottom, and then it flies back with minus on the top and plus on the bottom over and over again. This is the change of polarity on this coil going on here. You're sending that AC or that, back and forth polarity swap onto this vertical coil. And keep in mind that it's a stronger field here because the 9 volts hitting the vertical coil is a very weak 9 volt, very little current. It's just mainly voltage potential. So the stronger polarity will override the weaker. But in between the switching of the polarity onto this vertical coil, this 9 volt is still there. It's plus 9 volts. It's still there. So you're sending another plus 9 volts and minus 9 volts, and then on the flyback on the right side, I'll put it in a different color. I'll put it in green, the flyback polarity, and minus and plus. So that's what's going on here. The vertical coil keeps seeing plus and minus and plus back and forth, but it sees plus and minus in orange in a strong field, and it sees minus and plus in a weak field because the flyback is a very low current, but it's a much higher voltage. So it's probably in 300 volts or more with very little current. So in orange, the plus and minus is 9 volts with a good amount of current. And then in green, it's minus and opposite polarity, but much higher voltage, let's say 300 volts, and very low current. So that impact of reverse polarity on the vertical coil at a high frequency because you got 20 kilo ohms on that on the trigger of the transistors there. That's a pretty high frequency with a low current. You know, it's still higher than what the flyback current is, but the flyback voltage is much higher. So what I'm saying is the current going into this coil is always going to be higher than the current going into this coil because there's no current going into that coil. It's just one side, 9 volts. It's just potentialized on one side. So I just see that vertical coil, the Tesla coil, as a receiver of the radiant field of the ether, the etheric field, because the scalar energy is moving. It's, how do I say, scalar waves move over the surface of the earth in a, you know, anything you have sitting vertical will pick up the whole wave, or at least part of that wave that's moving over the surface of the planet. So the wave is, the scalar waves are moving over the surface of the planet from plane to plane in all poles, northwest, east, south, north, northwest, south, southeast, whatever. An omnidirectional scalar wave around the globe or disk, whatever you want to call it. My point is, anything vertical will be impacted by that wave. Anything horizontal will receive a lot less impact because you're receiving less of the wave. If you're like this, you're only receiving this portion of a small section of the wave. If you're like this, you're receiving a bigger section of the wave. So that's the Tesla coil sitting vertical. Man, you never saw Mr. Tesla put his coil horizontal, did you? That's just my perspective and my view on this here. So let's say that the vertical coil is receiving the radiant. I'll check the chats here and there. What's up, guys? Let's say the vertical coil is receiving the radiant of the etheric field and being potentialized with, maybe that actually, being potentialized with the 9 volts. You know, on one side of the coil only, just giving it a 9-volt potential. That kind of, it's like a radio antenna, you know, to some degree. So let's say that this coil is receiving the radiant, the etheric signals, and you're hitting the coil with plus and minus from your battery and your one of your windings in the bifilar, and then the flyback hits the coil again in the opposite polarity. Don't you think that would have an impact on the amount of radiant being absorbed? You know the scalar wave is a wave, it's a wave, so that would be plus and minus as well. So this is just what I was thinking when I was looking at this. It's just some of the things that was coming to me in my, you're looking at a scalar wave, you know, plus and minus, you know, passing over the coil that's sitting vertical, you know. So you're hitting the coil with plus and minus. First you're hitting it with plus and minus from the 9 volts, when the gates close. A weak, not very strong, but there's still, again, there's still more current than the flyback, but a lower voltage. So you're also varying the current and the voltage hitting the vertical, which that variability of current and voltage on the vertical gives it more bandwidth, in my opinion, for reception. So This guy gets energized with 9 volts on the forward charge, impacts this and with that polarity with a semi-stronger field compared to the flyback. And then the flyback happens when the gates open in reverse polarity with a much higher voltage and a much weaker current. Perhaps the radiant comes in during the flyback cycle and the actual forward polarity push onto that vertical from the horizontal single wire bifilar is what I was going to say is prepping the vertical for the flyback cycle, the higher voltage influence. Whatever. I just think the vertical is responsible for this circuit is lighting up. Pachuka puts a light bulb across these 2 points of the secondary winding on the bifilar. He puts the light here. Okay. And what does he do to get this thing started? He taps the negative 1 time and hits this with 9 volts. That first initiation of energizing this coil here gets it going, and it keeps running the light. So what's going on here? So if the vertical is the radiant receiver, the antenna of the etheric energy coming into the circuit, how does it get into the circuit? Let's go over that. Let's figure this one out. How does it get in? It has to get in wirelessly isolated somehow, because it probably does get in there wirelessly. Because this is the stator coil picking up all the action. Now these 2 coils are a bifilar. They're wrapped around together, so a pancake horizontal sitting coil. And this guy is sitting in the middle of those 2 coils vertically. So everything that hits this coil also, which is a good amount of efficiency. So every time you send your plus and minus in orange on this coil, one winding of the bifilar, it goes to this winding. And then when this coil flies back in reverse polarity, it also goes to this coil. And that's the meaning of the full bridge rectifier, because the polarity changes. So when the polarity changes, okay, so what happens is when you send plus here and minus here from your forward charge of the battery, well, it's conserving whatever's not used and sending it back to the circuit like so. Plus on the capacitor here. So that's how it's doing that. It's conserving whatever you're not using, sending it back to the capacitor, and minus will go this way on 1/2 of the bridge. Okay, and then when it flies back in reverse polarity, we already did use this half of the bridge for the forward pulse. Now the flyback polarity is going to go into the other half of the bridge like so. Here's in green, the flyback polarity, plus through the other half of the bridge, the same plus of the capacitor. And the minus of the flyback in green goes through this part of the bridge to the minus of the capacitor. So on both polarities of the activity of the primary winding of the pancake bifilar is being absorbed to the secondary winding of the bifilar and rectified back to this capacitor right here. So whatever when he taps the negative 9 volts and it charges up this coil, it sends the energy back to this capacitor. And then this capacitor runs the circuit, sends this plus 9 volts back to the circuit and sends the minus over here. The circuit keeps running. The capacitor takes over as the source. This is just the starting energy. And then the capacitor takes over as the source. And so again, everything that the capacitor sends to this coil gets sent back to the secondary and back to the capacitor through the rectifier, and so on. In between all of that, vertically sitting is the horizontal, or the vertical Tesla coil, receiving these reverse polarity flips from low voltage one polarity and high voltage the other polarity. A small current on one polarity and then an even smaller current with a higher voltage on the other polarity. That's a lot of a huge differential in activity there, which would cause that antenna to be more receptive as far as differentials go. And if you know what differentials means, then that would lead you to understand why this vertical coil is picking up the extra bit of little juice it needs to keep this capacitor charged. And how is it getting to there? How is it getting to there? The same way that this coil horizontal sitting gets to the vertical coil wirelessly. And then this vertical coil gets to the secondary of the pancake wirelessly. So whatever radiant is picked up on this vertical coil is transmitted to the horizontal coil wirelessly from vertical to horizontal plane. So you're sending the scalar vertical energy. Well, the scalar energy is traveling over the surface of the Earth, but it's a big field, so it's not high. I mean, I don't think scalar energy is high frequency. I could be wrong, but I'm pretty sure it's low frequencies because they're big waves, And yeah, so that's my opinion on how this thing is self-running. The vertical coil is picking up scalar energy, transmitting it to the horizontal field wirelessly. Because the vertical coil is going to radiate like this. It's going to radiate sort of like the scalar waves radiate. Plus and minus, remember, it's a wave. So you're going to have curves up and curves down. The curves up. Okay, let's do the curve up. The curve up will go in a circle. So any curve up will go in a circle. I don't think those up curves will hit the horizontal coil sitting below. But the down curves will. So probably this portion of the vertical coil will hit the pancake sitting right here. And then you got another down curve right here. You also have at this bottom portion of the coil, you have an up curve right here. Up of and then, so how do I put this here? You got the sine wave like that at the bottom portion of the coil. And then again, another sine wave. And the other, looks like a dude with glasses. So you're hitting the pancake coil here, plus and minus on each side. Okay, so the pancake coil is receiving from the vertical, at least at this bottom portion of the vertical coil is getting there. I wouldn't be surprised, depending on how big the scalar waves are that are being absorbed onto this coil through this interaction of from our activity from the circuit, producing plus and minus and flyback and reverse polarity and all that stuff onto the vertical coil. I wouldn't be surprised that the scalar waves are pretty big. They're probably huge, probably going like that around the whole table, from the top to the bottom. If that's the case, then there's a ton of energy hitting this pancake coil sitting at the bottom here. I mean, no, I wouldn't say a ton of energy, but there's enough to keep that light bulb running. And the link to the video is in the description of this live stream. And you can see how he taps the 9 volt to get it started, and it just keeps running. I asked him, what do you think's going on here? I said, do you think the flyback has something to do with it self-running? He said, it's hard to tell. I don't think he fully understands what's going on either. And I can't say that I figured it out. I'm just giving you my perspective of what I think is going on based on what I know. So, yeah, that's that. Quick one on the Pachuka circuit. I guess nobody's really that interested in this. They don't believe it. Whatever. So yeah, this vertical coil is not doing anything other than receiving positive 9 volts on one end and acting like an antenna sitting close by to the pancake coil bifilar. So I'm definitely going to replicate this. I like the efficiency of it overall. Everything hitting this phase, this winding of the bifilar, hits this winding of the bifilar and gets rectified back to a capacitor. I think that's super efficient. And if AC is hitting this winding, or a reverse in polarity, which is the case because we already went over that. There is a reverse polarity hitting this winding here. Okay. A one phase of the circuit operation, plus hits the top, minus hits the bottom, and the other phase, minus hits the top, plus hits the bottom. When plus hits here, it goes through one half of the bridge to the capacitor, plus of the capacitor, and minus goes this way. The other polarity of this activity hitting this secondary goes this way through the other half of the bridge, the opposite half, to the same plus of the capacitor, and this minus goes. Highly efficient, if you ask me. Very little room for wasting energy here, other than the primary of the pancake bifilar sitting horizontal. This is where the energy is used. Not much energy, keep in mind, because you got 20 kilo ohms of resistance on these triggers for these two transistors, and it's double pole switched, by the way, which is I don't know why he needed to do that. I'm trying to figure that out, why he couldn't single pole switch. Why did he double pole switch? Probably because he needed to get this 9 volts. Oops. I'm saying because I think the reason why he double pole switched because he needed to get this 9 volts over to the Tesla coil sitting vertical. And he could have sent the 9 volts over there directly, but he wanted to send it through the primary winding of the bifilar, which gets triggered. That's another thing I wanted to mention. This winding, so the 9 volts getting from the battery to that Tesla coil, sitting vertical, has to go through that trigger winding. Oops, sorry. It has to go through this trigger winding and the 20 kilo ohms. So what do you think happens when you're 9 volts positive getting there is slightly interrupted by the energization of this coil? That's another interesting thing. When you energize this primary of the pancake bifilar, you're impacting the way this vertical receives that 9 volts because there's a slight voltage drop going on there. Maybe when that happens, that's when that potential drop on the vertical Tesla coil for that moment in time allows atmospheric pressure or scalar pressure to come into the coil. And that happens when the transistors the gates are closed and the primary is getting energy. Because again, the 9 volt has to channel through that same primary of the pancake. And when that primary of the pancake receives energy from the capacitor, assuming you got it started already. Okay, now once you get the thing started, the 9 volts is here on the capacitor, so the capacitor is feeding it, keeping this 9 volts there. And then you energize this coil when you close the transistors, and this 9 volts feels that impact. Maybe it drops to 8.7 or 8.8 or 8.9. That slight drop, allows the pressure from the outside environment into this coil, into the vertical with the scalar field. And that slight drop of pressure is happening at a high frequency, so it's happening multiple times a second. So every time you energize this coil, a little bit comes in here at whatever frequency 20 kilo ohms creates, which could be, I don't know, let's say 15,000 hertz or something. I don't know. Yeah, that's another thing I wanted to say about this vertical coil and how it's influenced by this circuit. And you have to keep in mind that the primary of the pancake coil is also changing polarity with each flyback cycle. And when it flies back in reverse polarity, that also affects how this 9 volt sits on this side of the antenna. All right, I don't know. You guys are gonna have to comment on this for me to keep going. This is there is no you guys here because Friday night eating popcorn, yapping with your girlfriend. So when you get around this video and you see it, and I triggered any thoughts in your head, comment what you think is going on. What is it you think is happening here? So I see that vertical coil as, without it, the thing doesn't run itself, doesn't keep the light on, and you're going to need to supply it with constant energy. But if you look at the video and the link on this live stream to Pachuka's channel, through, goes right to this video, to this particular circuit, and you can see how the light's just shining, and you know, there's no tricks going on here. He doesn't have a wireless EMF transmission going on or nothing. It's all, yeah, this is Tesla's vertical coil doing that action. This is the secret of the Tesla coil. Why did Tesla have the Tesla coil sitting vertical? Why isn't there? You never see that coil sitting horizontal. You always see it standing up. That's because it's designed to capture scalar waves, which are going over the surface of the planet like big waves. Anything sitting vertical is going to pick up a large portion of that wave. You sit a coil like this, you're not going to get much out of it. All right, over now, guys.